Hi, U.S. Army Railroad Design and Rehabilitation TI 850-02 Kemp E Railroad Rehabilitation and Design U.S. Army Corps Engineering Chapter 4 Route Selection 1 Introduction. The chapter describes the process of selecting a route of the track connecting the terminal facilities of commercial railroad servicing installation. B. The location of the process begins with roughly defining the potential routes and areas where the railroad might particularly run. Additional more detailed information is then collected, routed, alternatives grounded, reduced, and the final result is shown. And before the process begins, the initial location, orientation, terminal facilities described in Chapter 8 should be completed. The ideal route is usually one of the shortest length, the how the longest, lowest of the grade, how the least curvature, and cost of less to build, least to build, most convenient service installation in all terminals, as well as connecting carriers. 6. Causes the least interference with other activities and modes of transportation. 7. Environmental capability with adjacent land use. 8. Provides reliable use of all weather conditions. B. Since all the above objectives are often conflict, the engineer's job is to determine the appropriate compromise that will produce the best route under the circumstances. The one best meets the objectives. If initial locations prove unsatisfactory in some important aspects, it may be desirable to look for a different location and reorientate the terminal so that the line can serve in a different direction. Throughout the route of the selection process, it is essential to have good maps, including contour maps of the area which the railroad may run. If not currently available, they should be obtained in the first step. 2. Establishing control points and potential corridors. Control points serve the limited location alternatives represent places through which the railroad must pass would ideally pass. B. The most obvious control points are endpoints, terminal, and connections with the commercial railroad. Immediately control points may be established with facility. Geographical features must be avoided with such as firing ranges, areas that cannot be drained well, environmental sensitive areas. Control points can also be placed other significant construction operating advantages such as narrow, shallow river crossing and or naturally good drainage. 3. After control points of the mark of the contour aerial max approximate boundaries of the potential route of the corridors are sketched. More control points often are other than important needed to define specific route are identified in the next stage of reconnaissance. 3. Reconnaissance. The reconnaissance is the quick examination of a wide strip of land between the control points. The strip represents the boundary of potential line location. Several routes or alternatives for portions of a route may be examined. The purpose of reconnaissance is to identify the routes that may allow with the easiest construction after consistent with the purpose of the requirements of the railroad. See the contour maps, aerial paragraphs, previous survey information with the good service during the reconnaissance, small set of the maps, the diagrams with the control and potential routes identified with the convenient of the field use. The information gathered during the reconnaissance can be then transferred to the larger maps and computer file backs in the offices. Reconnaissance may be done at many appropriate terrain distances covered, walking, driving, air from the air. General taking the note of the terrain, anything that might be affect the route of the location of the construction. Look for especially for landmarks, reference to location, additional control points, areas of potential ease and difficulty, construction, road, utility lines to be crossed, waterways and ravines to be crossed, estimated length and height of bridges, drainage paths, soil conditions, geographical features, vegetation type, potential future additions to the railroad as per installation master plan, wet plans, or other environmental sensitive areas. 11. Snowfall exposure to the drifting snow. Snow conditions along with the proposed route should be observed for at least one winter to identify locations where the drifts, while aerial photographs may be used for helpful for the purpose. The site of the downward frozen lake should be avoided unless inadequate between the shores and the roadway installation snow fences. After the reconnaissance has been completed, prepare the maps and showing all the controls of the potential alternative routes. This may make general comparisons between the routes with respect to length, grades, curvature, ring, relative amount of earthwork, drainage work, required bridge work, special requirements, potential operating advantages, disadvantages. Insufficient information is available for the point recommended best route. Other priorities route also note the special requirements internal and initial survey. The initial survey. The objective of the initial survey is to obtain sufficient information to allow preparation of initial earthwork, construction estimates, and establish location of the track, drainage path, Pet maps that back at the office which route the choice of the clearance with the reconnaissance initial final surveys that they often combine. B. The initial survey is done approximately with the routes and the serious tangents and taking evaluation cross-section data and selected intervals, perhaps 100 to 200 feet along the route. Generally, whether the terrain is fairly uniform, the longer the survey intervals can be used. The elevation cross-section data should also be taken points in representing a rapid change in the terrain and other points of special interest that may be used as you aid construction estimating. All useful landmarks should also be tied to the survey stakes. Need to be given a sufficient number to clear the show the survey center line about every 200 to 400 feet. For the crossing section, nearby elevation right angle to the route, simply take an elevation point and that will shape the adjacent terrain, local peaks, local points, and other points of special interest. The wide required cross section will dictate the character of the terrain, right of the way of ownership, the distance needed to show the local drainage topographical features. It is not necessary for the cross section to be equal distance on each side of the route of the center line or equal to the width of each station along the route. When terrain is open and easily accessible, the cross-section data is often taken 300 to 500 feet on each side of the route center line. Anywhere the route location is fairly well defined. Cross-sections may be narrower, sometimes with 50 feet wide strip is needed. The situation should be governed in choice of the width. When they're approaching where the change in the direction occurs, it will often behoove use to take in an extra wide cross section inside the angle of the cross curve of the eventual connecting the two tangents through the area. During the initial survey, to take sufficient information to establish drainage passages on both sides of the track. Also note on the drain runoff the right way, as well as the outlets where the water can exist in the right way, the nearby streams and drop inlets of the runoff channels. 5. The trial location process determination of potential particular routes, trial routes through the particular area. The objective of the trial location is produced as the best combination of the tangents, curved grades of the route surveyed. This is done by combining the survey information design, economical guides, operating requirements, engineering judgment. During the process, many of the factors must be weighed and prioritized. Conflicting objectives must be balanced. B. After the first trial routes are located, the construction estimated are made at the location of the train and the drainage path. Usually method modified in an attempt to reduce the construction cost, which will still maintain satisfactory operation characteristics, or to improve operating characteristics will keep the contracting cost at a reasonable level. Adjusting it are made to each of the route until the compromise has been produced. C. For the track of the installation or in the terminal area, the process can usually be simplified, done by fewer iterations. Likewise, the construction estimates might be done only once. D. The track location assigned by the light sketching the boundary initial survey on the counter map. The first route of the drawing through this strip is often done by the minimizing grade flatter territory by the minimizing the number of the curves needed. As with the initial survey, the route begins a series of the connected tangents with the curves chosen and drawn later. After the route is sketched as a profile drawn, the elevation of the railroad curve come from the evaluation end of the intermediate point of the differential gauge chosen between these points. The evaluation existing ground are obtained approximately with the point where the route would be passed through each of the crossing sections. Take an initial survey. When the initial survey is done, the ground evaluation are taken to the points when the route of the crossing mapped contours. When the trail routes are drawn, earthwork construction estimates are used to doing the standard procedures as the stage of the embankment cut in width and slope angles may be estimated using the typical roadway crossing of the Chapter 6, Paragraph 1. If one of the route does not appear clearly superior, additional terrain, additional iteration or modification analysis may be needed to produce the final location. 6. The final location. To finalize the route selection, modifications may be made to the trial routes in an attempt to even the cut and fill amounts of the adjacent area to reduce the total earthwork and grading required. Where the grades of curvature exceed most of the desired routes should be modified if feasible to reduce these. The criteria listed in Chapter 4 and Paragraph 1 should also be reviewed in trial route. Chapter 5, Rehabilitation Tracks, Bridges, and Terminals.